Properties of solutions. We've looked at solutions before. They are homogeneous mixtures, which means they have one phase when you look at them. There are two parts of every solution. There is the solute, which is what is dissolved, and the solvent, which is the portion that does the dissolving. Most commonly, the solvent is water. That's what does the dissolving, and the solute could be a solid, liquid, or gas that's dissolved in the water. So a substance will dissolve based on the compositions of the solute and solvent. We're going to look at three things that determine how quickly a solute will dissolve. Number one, stirring. When you stir the solute into the solvent, that speeds up the dissolving process because fresh solvent is continually brought into contact with solute particles. That's why when you stir sugar into tea, it will speed up the dissolving process. Temperature will speed up the dissolving process if you increase the temperature because the more kinetic energy causes the particles to move faster. This increases the frequency and force of collisions between solute and solvent. And then the third thing we can do to speed up the dissolving process is particle size. Smaller particles dissolve more quickly than larger particles because there is a greater surface area exposed with smaller particles. So these are three ways that we can increase the rate of the dissolving process between the solute and the solvent. A saturated solution contains the maximum amount of solute for a given quantity of solvent. For example, 36.2 grams of sodium chloride will dissolve in 100 grams of water. If I put any more than 36.2 grams into 100 grams of water, it will not dissolve. It is already saturated. It contains the maximum amount possible for solute. So solubility is a measure of the amount of solute that dissolves in a given quantity of solvents to produce a saturated solution. So solubility is how much solute can dissolve in a given quantity of solvent. You also have unsaturated solutions which contain less solute than a saturated solution. So if I add more solute to an unsaturated solution, that solute will dissolve because it's not yet saturated. Miscible is a term for two liquids that will dissolve in each other in all proportions. Water and ethanol will mix. They are miscible. Immiscible means liquids are insoluble. They will not mix. Water and oil will not mix. They are immiscible. So here are two factors that will affect solubility. Solubility is how much solute I can get to dissolve. For most solid substances, the solubility increases as the temperature increases. For a few substances, it's opposite, but we're not going to worry about that. For most substances, the solubility increases as the temperature increases. So if the temperature increases, I can get more solute to dissolve. Which leads us to the third type of solution. Supersaturated contains more solute than it can theoretically hold at a given temperature, and this only occurs when you have a saturated solution and you allow it to cool. Because the temperature is changing, the solubility is changing, and this will crystallize rapidly when disturbed. Now, the solubilities of gases are greater in cold water than hot water. This is opposite of solids. So temperature affects how much solute I can get to dissolve. Pressure also affects how much solute I can get to dissolve. Now, liquids and solids are not greatly affected by changes in pressure, but the solubility of gases is strongly influenced by pressure. Gas solubility increases as the partial pressure of the gas above the solution increases. For example, carbonated sodas. Carbonated sodas have a gas pocket right there, which contains large amounts of CO2 dissolved in water, but I also have some CO2 in that airspace. When you open a carbonated soda, the partial pressure of the CO2 above the liquid decreases. So when you open a soda, this pressure right here of this gas decreases. So you will have bubbles of CO2 escape from the liquid, and the drink will become flat over time because the CO2 is escaping from the liquid. So pressure affects gas solubility, how much gas I can get to dissolve in a given quantity of solvent. Henry's law relates the solubility of a gas to the pressure of the gas above the liquid. S1 over P1 equals S2 over P2. In this example, I want to know the solubility when the pressure is increased to 288 kilopascals. It looks like the gas laws that we've done previously, except this relates solubility. So S1, 0.16 grams per liter. P1, 104 kPa. I want to find S2 at the new pressure, which is 288 kilopascals. So the solubility of this gas in water, the pressure goes up, the solubility goes up, 0.44, and the units for solubility are grams per liter.